Welcome once again back to my YouTube channel. Continuation of my previous video, whether the transformation is canonical. Continuation of the problem what we have seen in the previous video. I am going to solve remaining part of the problem in this video. For showing the transformation is canonical, I am using the concept of Poisson bracket. If the Poisson bracket Q comma P is 1, then we say that the transformation is canonical. What is the value for Poisson bracket Q comma P? Is nothing but determinant dou Q by dou small q, dou Q by dou small p, dou P by dou small q, dou P by dou small p, which is equivalent to 1. What is the value for determinant of first row dou Q by dou small q? The answer is e power alpha cos p root 2q, root 2 into 1 by 2 root q. We have already found out the answer for dou q by dou small q. What is the value for dou q by dou small p? Dou q by dou small p is nothing but minus of root 2q e power alpha sin p. This is first row. Similarly for second row, dou p by dou small q, the answer is e power minus alpha sin p root 2 into 1 by 2 root q. Dou p by dou small p, e power minus alpha root of 2q sin p becomes cos p. If you show this determinant value is equivalent to 1, then the transformation A is canonical. Answer is e power alpha into e power minus alpha cos square p root 2 by 2 into root q into root q. Root 2 root 2 root q divided by 2 root q. Root 2 will cancel with 2, root q will get cancelled. E power alpha into e power minus alpha. This is the value for e power alpha cos p root 2 1 by 2 root q into e power minus alpha root 2q cos p. Minus of minus plus again e power alpha e power minus alpha sin square p root 2 by 2 root q root of 2q. Again numerator and denominator will get cancelled. E power alpha, e power minus alpha, e power 0, that is 1. The answer is cos square p. Similarly, e power alpha, e power minus alpha, if you product, these two will get cancelled. Remaining term sin square p. Cos square p plus sin square p equivalent to 1. Therefore, option A is canonical. The transformation A is canonical. I am proving the concept by using Poisson bracket. Similarly, I am going to prove B and C whether it is canonical or not. Now What is B? What is B given as Q comma P, which is equivalent to Q tan P comma log sin P. This is Q, this is P. Similarly, I am using the concept of a Poisson bracket. If you show Poisson bracket value is 1, then we say that B transformation is canonical. Now I am going to find out dou Q by dou small q. Answer is tan P. Dou Q by dou small p. Answer is Q secant square P. Dou P by dou small q. There is no term in terms of Q, 0. Dou P by dou small p. Log sin P becomes 1 by sin P. For sin P, differentiation is minus cos P. Substitute all the values in equation 2. 2 implies Q comma P nothing but dou Q by dou small q, dou Q by dou small p, dou P by dou small q, dou P by dou small p. Dou Q by dou small q tan P Q secant square P 0 minus sin P differentiation is not minus cos P, becomes plus cos P. Simplification, this is nothing but cos P by plus cos P by sin P. The answer is which implies determinant tan P Q secant square P 0, it is cos P by sin P cot P. We have to show this is nothing but it is equivalent to 1, which implies tan P into cot P minus 0 equivalent to 1. What is tan P into cot P? Tan P is nothing but 1 by cot P into cot P. Cot P will get cancelled. The answer is 1. For this transformation, B is also canonical. A is canonical. Now B is also canonical. Now I am going for C. If C is canonical, then from the option fourth one is right, all are canonical. Now I am going to show whether C is canonical or not, again by using the concept of Poisson bracket Q comma P. What is given as C? What is C? Q comma P, which is equivalent to 1 by p comma q p square. This is q, this is p. Find dou q by dou small q. This is 0. Dou q by dou small p, this is nothing but 1 by p can be written as p power minus 1 p power minus 1 minus 1. Answer is minus 1 by p square. Now I am going to find dou p by dou small p 2pq. Dou p by dou small q, the answer is p square. Substitute in the Poisson bracket q comma p. Q comma p is nothing but dou q by dou small q, dou q by dou small p, dou p by dou small q, dou p by dou small p. If I show this value determinant is 1, then C transformation is canonical. Substitute the value 0 minus 1 by p square 2pq. Simplification, 0 plus 1 by p square into p square will cancel 1. Therefore C is canonical. Therefore all are for this problem, option 4 is correct. Thank you.